In this video we're going to talk about resonance, which is a continuation of the standing waves that we had in the last video. I'm going to draw a picture up here. You don't have to draw it, but I want to recall your mind to it. When I was doing the fundamental frequency for the spring, it was very easy for me to swing it in this shape at its fundamental frequency. I didn't have to put much energy into it, and I could get it swinging like this, and with just a little bit of energy I could actually build up a pretty big amplitude. When I tried to get to the second harmonic, like this, it took a little bit more energy, it was a little bit more difficult, and then the third harmonic was more difficult yet. But it's usually very easy to get something to vibrate at its natural frequency, or its fundamental frequency. Resonance is when something causes an object to vibrate at its natural or fundamental frequency. Now, there are a lot of examples of this. There's the spring. I put a little bit of energy into it and I get a big amplitude when I'm at the right frequency. If I take this pop bottle, okay, and I just blow across the top of it, it starts to vibrate at its natural frequency and produce that sound. So the something is my breath causing the air in the pop bottle to vibrate at its natural frequency. And there are a lot of examples. If you go to a concert and there's a lot of bass, your chest can start to thump because the frequency of that bass is close enough to the natural frequency of your chest that your chest will start to vibrate. A real-life example of this that was kind of important is this one. It is the Tacoma Narrows Bridge. It was a bridge built in the late 1930s, and shortly after it had been built, they started to notice it start to vibrate when the wind was the right speed. And eventually the wind was going the right speed, and it caused the bridge to start to vibrate at its fundamental frequency. And we end up with these giant waves going through the bridge. And so you can kind of see, like, that's steel and concrete. Those I-beams that you see on the side, if we get back to it, I mean, those are way taller than a car, so those oscillations are gigantic. This right here is a car. You probably can't see it very well, but these oscillations are bigger than the car. And shortly after this video was shot, this thing kept swinging larger and larger and larger, and eventually the whole thing collapsed. So resonance is pretty easy to understand, and it's something that is important to engineers. They have to know to plan for this resonance. Skyscrapers, they can start to sway at their natural frequency, and they have to be sure that they protect against that.